This is section 7.3, simplifying radical expressions. When we look here at the product rule for radicals, it says as long as the radical is the same radical, in this case it could be a square root times a square root, it could be a cube root times a cube root, fourth root times a fourth root, we can multiply like radicals together by multiplying what's underneath. For example, when we multiply the square root of 9 times the square root of 4, it's the same thing as saying the square root of 9 times 4, which is the square root of 36, which is 6. So let's do a few examples. We're going to multiply the square root of 3 and the square root of 5. That's the square root of 15. The next one we're going to multiply to get the square root of 21 and x, which is 21x. Here we've got the cube root of 4 times 2, which is 8. Of course, the cube root of 8 is a perfect cube, if you can remember back in 7.1, which is going to be 2. For D, we're going to get the fourth root of 5 times 2, which is 10. Oops. And then y squared times x cubed, we're going to just combine those and get y squared x cubed, and I need to extend that out. Here we're going to multiply the fractions together. Remember, you're going to multiply the top together to get 2b. We're going to multiply the bottom two together to get 3a. Can't write the a's. Okay. Says using the quotient rule says that if you're gonna if you've got a radical that's got a fraction underneath, you can take the top and the bottom, separate each of them out. For example, I could do the square root of 4 over 9 and get the square root of 4 over the square root of 9. Pen is not wanting to write, which will end up getting 2 over 3. So let's look at some examples here. Alright, so here you can leave it as it is and just do the top and the bottom separately, or we can just split it and do the square root of 25, the square root of 49, which will be 5 over 7. Here we can do the square root of x over the square root of 9, which will be the square root of x over 3. Here we've got the cube root of 8. We've got the cube root of 27. Cube root of 8 is 2. Cube root of 27 is 3. And then here we've got the fourth root of 3 over the fourth root of 16y to the fourth. Well, can't do anything with the fourth root of 3. But here for the bottom, the fourth root of 16 is going to be 2. And then we'll divide 4 into this 4, and that'll just be 2y. Alright, so we're going to simplify the radicals. These are not perfect squares, so to simplify a radical, what we're going to do is break this into perfect squares or into perfect cubes. Let's look at our perfect squares. I'm not going to do 1. Our perfect squares will be 4, 9, 16, 25, 36, 49, 64, 81, 100, 121. If we need to go higher, we can, but that's the first 11. Our perfect cubes, we've got 8, we've got 27, we've got 64, and we've got 125. So let's look at the square root of 50 and let's break it into factors. Let's do the perfect square factors. Of course, if we look, we see that 25 is a factor, so 25 times 2, we can separate those two out as the square root of 25, the square root of 2, which will be 5 square root of 2. Here we got a cube, so we're going to look at our list here and think, okay, well obviously 27 and 64 and 25 are not going to work. 8 is a factor of 24, so let's break it into 8 times 3, and we'll do the cube root of 8 times the cube root of 3, which will be 2 cube root of 3. 26, we got the square root of 26. If we look at our list here, 4 is not a factor, 9 is not a factor, neither is 16, and of course 25 is not going to work. So this one here is just going to stay the square root of 26 because it doesn't contain a perfect square factor. For the fourth root of 32, let's think about, I don't have my fourth roots here, but if we think about our fourth root, 16 is a perfect fourth. 16 times 2 is 32, so let's split the fourth root of 16, the fourth root of 2, and we'll get here 2 fourth root of 2 as our simplified radical. Alright, here we're going to use the product rule to simplify. So what we're going to do is simplify these radicals. We're going to split this thing up. We're going to split it into perfect square factors. Well, 25 is a perfect square. X cubed, we can actually split this up into a perfect square, which x squared. So let's do this. We're going to do the square root of 25. We're going to split the cube into x squared. That's going to leave us with just an x left over here. Both together gives us the x cubed. Here we'll take the square root of this and get 5x, and we'll leave the square root of x as it is. Here we've got the cube root. We're going to look at 54 first. So we've got the cube root. 54, what I'm going to do, let's split it up into 27 times 2. X to the 6 is going to be a perfect cube because it's a multiple of 3. So we're going to leave it as x to the 6. And then y to the 8, we're going to split into y to the 6 times y to the 2nd. Now what we'll do is we will break this thing down. We'll put our perfect cubes together. We'll do 27 x to the 6, y to the 6 times, and then over here we'll leave what are not perfect cubes, which is 2 and the y squared. Take the cube root of these perfect cubes, you're going to get 3x. Remember, you're dividing the root into the exponent. You get x squared and then a y squared, and we'll bring down the 2y squared. Here we've got the fourth root of 81, z to the 11, so we'll break this one down. 81 is a perfect fourth. 11 is not a perfect fourth, but we can split it into a multiple of 4. The smallest one will be y to the 8, which will leave us with, not y, sorry, it's z. Erase that. Z to the 8 and z to the what's left over, which is 4. Not 4, 3. Write that up. 3. All right, let's put our fourths together. 81 z to the 8, and we'll be left with the fourth root of z cubed. Take the fourth root here. We're going to get 3z squared because you divide 4 into 8, and then the fourth root of z cubed. Alright, so use quotient rules. So here we've got the radical. Since both of them are right, we can divide like the parts. And here, in this case, since 20 and 5 are the radicand, we can actually reduce this and divide 20 or 5 into 20 to get the square root of 4, which is going to be 2. Here we can simplify. What we want to do here is let's take out, we'll split this 2 here since it's not under a radical. Let's just put that as 1/2, and then let's put the radical 50x over the square root of 2 together, and let's divide the square root of 2 into the square root of 50, which that's going to give us 1/2 times the square root of 25x. Now what we can do is, notice that 25 is a perfect square. We can say that's going to be 5x is just going to stay the square root of x. And then if we multiply those together, that's 5/2 square root of x, not 2, x, which we're going to put the radical on the top with the 5. Alright, so see here, what we're going to do is we're going to leave the 7 out to the side. We're going to take the cube root of 48x to the 4, y to the 8. We're going to divide it by the cube root of 6y squared. Alright, 48 divided by 6, so we'll leave the 7, is going to be the cube root of 8. Here what we're going to have is we're going to leave x to the 4th, and we're going to use our quotient rule of exponents that says we can subtract the exponents when we're dividing. So when we subtract, that gives us y to the 6th. Alright, now we've got the cube root of 8, so let's split this up. Actually, you don't have to split it up, so let's just do this. We've got 7 times the cube root of 8 is going to be 2. Divide 3 into x to the 4. 3 will go into 4 one time, and we're going to have 1 left over under the radical, and then we can divide 3 into the 6 to get it y squared. So I'm going to keep my radical. I'm going to have an x under there. And then the last step is to multiply the 7 and the 2 together to get 14x y squared in front with the cube root of x underneath. Alright, last one here. So we can do some simplifying in this radical. So that's going to be the 4th root of, we're going to leave 32. Alright, we're going to subtract 8 minus a -1. That double negative makes that positive, so that's a to the 9. Here we're going to subtract 2 from 6 to get b to the 4th. Now we can split this up. I'll do this one like we have been. We'll do the 4th root of 32. Well, that can split into 16 times 2. Alright, well, I'm looking for multiples of 4, so we've got a to the 8 times a, and then multiples of 4, we're going to leave b to the 4th as it is. So let's put our perfect force in a radical together. So we're going to have a to the 8, b to the 4, and then what's going to be left is the 4th root of 2, and then we're going to have a over here. Alright, so take the 4th root, you're going to get 2, bring the 2 down, so here you're going to get 2a squared b, and then we'll multiply the 2's together to get 4a squared b, and then the 4th root of 2a.